Hello, and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com in the topic of kinematics. The title is acceleration. All right, first, before we can learn about acceleration, there's something that comes up in here that I haven't mentioned in my videos. You may have learned about it in class. If so, feel free to skip over it. And that is dot diagrams or ticker tape diagrams. They're called different things by different people. Physics classroom, I believe, calls them dot diagrams, although I've seen places where they call them ticker tape diagrams as well. So what is a ticker tape diagram? Well, this device is a device that used to be very commonly used in physics classrooms. What it did was this little thing bounced up and down 10 times each second. So it would leave a dot on a strip of paper once every 10th of a second. So if you pulled this tape through the ticker tape device, you would see a dot every 10th of a second, which means the tape, or whatever the tape was attached to, often it was attached to a car or a falling object or something like that, then each dot, it moved that far in a 10th of a second. Or you could measure 10 dots and it would move that far in 1 second. And so you could calculate the speed of how fast it was going. Okay? Because people aren't super familiar with this, I like to picture dot diagrams, these dots, as though a car were driving along, dripping oil every 10th of a second. I think that gives you a little bit of a better visual because the thing that's moving is the thing leaving the drops on a stationary surface instead of a stationary thing leaving drops on a moving surface. Either way, it's an accurate representation of the motion of an object. So this is what they will often look like. You'll see dots. If they're far apart, that means it moved a far distance in a 10th of a second, and that would mean it's going fast. If it didn't move very far in a 10th of a second, then it's going slow. Okay, so the farther apart each dot is, the faster it's going. Okay, if we want to imagine these are one second dots, because you could make it tick at any rate, it'd be like 1, 2, 3, 4, 5. Here it'd be, whoa, go back. Here it'd be 1, 2, 3, 4, 5, 6, 7. You see it's going slower because it's not getting as far each second. Then what's really important for today is this idea of constant speed and acceleration. We're going to come back to that later. In just a moment, we're going to learn that accelerating is when you change your velocity. So here we can see it goes 1, 2, 3, 4, 5. And here it goes 1, 2, 3, 4, 5, 6. You can see it was speeding up. Okay, or 1, 2, 3, 4. I counted a little bit fast there, but you get the idea. Okay, and if these were going the other direction, it'd be slowing down. 1, 2, 3, 4, 5, 6, 7, 8. Okay, slowing down. So that's the idea of a ticker tape. That's what we're seeing here. And so let's get on to the definition of acceleration. So first of all, velocity, which is tied in, which is a part of what acceleration is. It's not acceleration. Velocity is the rate at which a position changes, right? How much does the position change each second? Well, acceleration is the rate at which velocity changes. So how much does the velocity change each second? If you picture yourself inside the object in the cockpit or in the driver's seat of whatever the moving object is, and you were looking at a speedometer, which tells you your speed, or if you add direction, it would tell you your velocity, okay? Then how much does that speedometer change each second? That's what acceleration is. Now, acceleration will confuse a lot of students because, let me put it this way, if acceleration is the rate at which the velocity changes and velocity is the rate at which the position changes, that means acceleration is the rate at which the position changes. The rate of a rate? Oh my goodness, no wonder it's confusing. Okay, so be sure you stop and think about it. One really helpful thing is picturing yourself in the driver's seat watching the speedometer. Okay, so a couple examples of acceleration when you're falling, like on a roller coaster. You know that as you're falling, the first second, your speed doesn't change much. But as you keep falling, your speed is changing speed is getting bigger and bigger and bigger. That means you're accelerating because your speed is changing. Okay, another example would be a race car, right? Starting out stationary at the start line, they wave the green flag, I think it is. I'm not much of a car race guy. They drop the green flag or wave the green flag, and this car takes off, right? His speedometer goes from 0 to 10 to 20 to 30 to 40. That means he's accelerating because his velocity is changing. All right, let's get into the concept builder itself. So in the apprentice level, you are just trying to figure out, is the velocity changing? Because it asks you, is it accelerating? Okay. If the velocity is changing, then yes, it's accelerating. Now, keep in mind, we in like an English class or in a novel or something, accelerating would mean it's speeding up, and decelerating would mean it's slowing down. Here we deal with the slowing down with a negative sign. We're dealing with direction, but all of it is called accelerating. So if the velocity is changing, no matter what, then it's accelerating. Okay. If it is not, then it is not accelerating. Okay. Remember, there are 3 types of problems you'll see. You'll see word problems where it says things like a rightward moving car slows down from 35 meters per second to 10 meters per second. Is it accelerating? Well, did the velocity change? Yes, it was 35 and then 10. So yes, it is accelerating. If the rightward moving car was going 35 meters per second and then it was still going 35 meters per second, that would not be changing its velocity and therefore would not be accelerating. Second one you see, I didn't put an example of, but it will have time and speed and a little table. Okay, and it'll go 0, 1, 2. And if this number is changing to 4, 6, then it is yes, because the speed is changing. If it is 4, 4, 4, then the speed is not changing, so it'd be a no. All right, and finally, you'll see what we just learned about the ticker tapes. Remember, if the dots are the same distance apart, that means every second it's moving the same distance. That means the velocity is staying the same the whole way. So that would be no, it is not accelerating. If you see the dots getting closer together or farther apart, then it is accelerating. Whether it's speeding up or slowing down, that is an acceleration. Okay, it just might be a negative acceleration. All right, so that's the apprentice level. Then on the master level, I guess I didn't have these come in one at a time. That's okay, we can focus here. If an object is speeding up, then its acceleration is the same direction as its velocity. Okay, just really quick. An object is moving that way, and then it's moving that way faster. You can see the change in these arrows is in the same direction as the object is moving. Okay, so if it's speeding up towards the west, then its acceleration is pointed west. If it's speeding up to the left, then its acceleration is to the left. On the other hand, if it is slowing down, then its acceleration is the opposite direction of the velocity. So if it's going to the right and it is slowing down, we can see the arrows getting shorter. In other words, the arrow is changing in the opposite direction than it is pointing. It's getting shorter. Okay, so therefore, if the object, like we see in the problem here, if the leftward train is slowing down, then the direction of the, that should say train's acceleration would be rightward, opposite of the direction it's moving. Okay, if it was leftward and speeding up, then it would be going leftward. Finally, on the ticker tapes, of course, this would not be accelerating, but that's not what you're going to see here. You're going to see ones that are accelerating. So in this case, it's getting faster and faster and faster towards the right. That means it would be, its acceleration is pointed right. If these were starting out farther apart, let me draw that. If they were starting out farther apart and getting closer together, okay, then it would be moving to the right. But because it's slowing down, it's getting closer and closer together, it's not moving as far each second, then its acceleration would be left. All right. In the wizard level, it has you do some calculations. So what's the equation? Well, acceleration is how much does the velocity change, not just whether it changes now, but how much does it change? Remember, delta always means change in. So how much does the velocity change divided by the time it took it to change that much? Okay, now it might be helpful for you to think of the change of velocity as final velocity minus initial velocity. That'll especially help you if you run into situations with a negative acceleration, meaning it's slowing down essentially, or accelerating the opposite direction that it's moving. In this particular concept builder, it doesn't have you write the acceleration as a negative number. Instead, you drop out the negative and just write the magnitude, how big is the acceleration, and then you use the negative to recognize you have to flip the direction from the way it's going, just like we did in the master level. Okay, so once again, acceleration will be measured in meters per second squared. Okay, so speed or velocity was measured in meters per second. We had that up here. And then we divided by seconds. That puts another seconds in the denominator. So we now have meters per second squared as our acceleration. Or if you prefer, you could think of it as meters per second per second. How much does the meters per second, the velocity, change each second? But that's equal to meters per second squared, and that's certainly a more shorthand way to write it, and you will very often see it written that way. All right, let's get into a sample problem. We're going to be using this equation right here to break down the change in velocity into final minus initial. By the way, change, anytime you see a change, you can do final minus initial. All right, so sample problem. A westward moving motorcycle slows down from 18 meters per second to 12 meters per second in 3 seconds. What is the magnitude? Okay, so let's write down our givens. We see we have a velocity that's 18 meters per second, and we have a velocity that is 12 meters per second. Okay, so let's take a look at which one's which. It slows down from this to 12. So from means this must be where it started. That's our initial value. And it's going to, so that means 2 must be the final value. Okay, so this is final velocity. This is initial velocity. Time equals 3 seconds. And we're looking for the acceleration because it says what is the magnitude and direction of the acceleration. That's our unknown. We'll expect it to be in meters per second squared. All right, so then we take our equation, A equals V final minus V initial divided by T. We plug in our values because we don't have to rearrange since it's already solved for us. We see 12 meters per second minus 18 meters per second. And we divide by 3 seconds. Okay, so we'll do a little intermediate step here. 12 minus 18 will give us negative 6 meters per second divided by 3 seconds. And that will give us negative 2 meters per second squared because we had a seconds. We had a seconds in the denominator there, and we had a seconds in the denominator there. So we get seconds squared. All right, now what does that mean? What do you type into your concept builder? Well, first of all, the magnitude is 2. So you type in 2 as the magnitude. The negative tells us that the acceleration is in the opposite direction of the velocities. Notice how the velocities were positive and the acceleration is negative. So the acceleration is in the opposite direction. The velocities were westward. That means that the acceleration must be eastward. Okay, so you'd type in 2 for magnitude and you'd click to east for the direction. Alrighty, sometimes you'll see this written with cars. Okay, they'll draw it like this. They'll have a little car. Yeah, that's my car. And then they'll say T equals 0, V equals 12 or 18 meters per second. And then they'll have a second car and they'll say t equals 3. So how much time did it take going from 0 to 3? It took 3 seconds. And velocity ends up being 12 meters per second. Okay, so you just have it in a picture form. You could have it in a picture form like this, which would be the same as the written form here. You also will see it in tables, time and velocity. Okay, and so you can pick any two, 0 and any one of the numbers that you see, and just pick the velocities that are next to it. So you do final velocity of 22, initial velocity of 2, and a time of 4. But you can pick any two rows, and you can calculate the acceleration. All right, have fun puzzling that out. If you have any questions, put them in the comments below. If you learned a lot from this video, please click that like and subscribe button, and we'll see you the next time on the scientific adventures of Beardman.